Hi, I am Rupal Gupta. I welcome you all to the mathematics classes. Today we will revise the representation of the various numbers on the number line, some important points while drawing our number line, how to count the number of integers between two integers, what are the fractions and how to represent it on number line, how many rational numbers are there between two rational numbers and how to find them. Let's revise the different types of numbers. We have learned about the natural number in the earlier classes. It starts from the 1 and extends indefinitely only to the right side of 1. ये numbers 1 से start होगा केवल right side up to the infinity. The whole numbers is also extends indefinitely or up to the infinity only to the right side. But it starts from 0. नेचुरल नंबर की तरह ये भी राइट साइड में ही होगा लेकिन स्टार्टिंग पॉइंट इसका 0 होगा. The integers are the numbers that are not in fraction and extends on both the sides of 0. On the left side of 0, you can see the negative integers like -1, -2, and on the right side, you can see the positive integers like +1, +2, and so on. For rational numbers, also the line extends on the both sides, as you can see here all the positive integers as well as all the negative integers. But now we can also see the numbers in between the integers like 1/2 in between 0 and 1 and 3/2 or 1.5 in between 1 and 2. Similarly, we can show these number on the negative side as well. जैसे कि यहाँ हमने -1/2 की पोजीशन -1 और 0 के बीच लाई करेगा एंड -3/2 की पोजीशन -2 और -1 के बीच होगा. इसकी वैल्यूज हम कैसे मार्क करते हैं ये हम आगे के लेक्चर में सीखेंगे. हमने ऑलरेडी नंबर लाइंस के बारे में पढ़ा है. नंबर लाइंस ड्रॉ करते समय हमें कुछ बातों का ध्यान रखना है. 0 हमेशा मिड में होगा और 0 के राइट साइड में हमें पॉजिटिव नंबर्स को शो करना है एंड लेफ्ट साइड में हमें नेगेटिव नंबर्स को शो करना है. All the consecutive numbers marked on the number line will be equally spaced from each other. They must be in order like 1, 2, 3 and -1, -2 and -3. अगर हमने दो consecutive numbers के बीच का distance 1 सेंटीमीटर लिया है तो हमें rest of the numbers के लिए भी same distance रखना होगा. यहाँ आप इस नंबर लाइन को देख सकते हैं. इसमें पहले नंबर लाइन के कंपैरिजन में स्पेस हर नंबर के बीच ज्यादा है बट कंसिस्टेंट है क्योंकि हर नंबर के बीच सेम स्पेस है. सो इट इज अ वैलिड नंबर लाइन. Similarly, this number line is also valid because every point on the line is equally spaced. Could you predict whether this line is valid or not? Yes, correct. It's invalid. Since the space between these points are not equal, so it is not a valid number line. हमें नंबर्स को हमेशा इक्वली स्पेस देकर रखना है और उनका ऑर्डर हम चेंज नहीं कर सकते. Let us represent the fraction number on number line. There are two types of fractions, namely proper fraction and improper fraction. Let us first study about the proper fraction. We know that proper fractions are those in which numerator is less than the denominator as shown here. They always lie between only 0 and 1. Some of the examples given are 1/2, 4/5 and 9/11. हम यहाँ हर केस में देख सकते हैं कि न्यूमरेटर डिनोमिनेटर से कम है. जैसे 1 2 से छोटा है. सिमिलरली हियर 9 11 से कम है तो ऐसे नंबर हमेशा 0 से बड़े और 1 से छोटे होंगे। They are always less than 1 and greater than 0. So the proper fractions always exist between 0 and 1 on number line. In the negative numbers, consider only the value, not the sign. -1/2 and -9/11 में न्यूमरेटर एंड डिनोमिनेटर को कंपेयर करते समय हम केवल 1 and 2 और यहाँ 9 and 11 को कंपेयर करेंगे। ये नंबर भी लेस देन 1 है और नंबर लाइन पर -1 and 0 के बीच लाई करेगा, एज दे आर नेगेटिव नंबर्स। Improper fractions are those in which numerator of the fraction will be greater than its denominator. Like 12.5, 12 is greater than 5, so it is an improper fraction. These numbers are always greater than 1 because the numerator is greater than the denominator. हम पहले इम्प्रॉपर फ्रैक्शन को मिक्स फ्रैक्शन में कन्वर्ट करेंगे तो हमें ये पता चल जाएगा कि फ्रैक्शन किन दो नंबर के बीच लाई करेगा। जैसे कि मिक्स फ्रैक्शन का फॉर्म यहाँ दिया गया है QR/D, वेयर Q is a whole number and R/D is a fraction. So number lies between Q and Q+1. Let us learn how to convert the fraction into mixed fraction. मिक्स फ्रैक्शन फॉर्म में लिखने के लिए हम न्यूमरेटर को डिनोमिनेटर से डिवाइड करेंगे। वी नो दैट व्हेन वी डिवाइड अ डिविडेंड बाय अ डिवाइजर वी गेट सम कोशेंट एंड रिमाइंडर। नाउ फॉर 3/2, इफ वी डिवाइड 3/2 it will go by 1 and there would be 1 as a remainder. So we can write 3/2 as a 1 whole number plus 1/2. That means this number lie between itself, that is 1, and the next number, that is 2. So 3/2 lie between 1 and 2. Similarly 12/5 में हम 12 को 5 से डिवाइड करेंगे तो हमें कोशेंट 2 मिलेगा एंड रिमाइंडर 2। हम 12/5 को मिक्स्ड फ्रैक्शन के फॉर्म में लिख सकते हैं लाइक QR/D। तो 12/5 बन जाएगा 2/5 and this number tell us that its position lie between 2 and 3. हमेशा जो यहाँ होल नंबर होगा उस नंबर से नेक्स्ट नंबर के बीच हमारा फ्रैक्शन की पोजीशन लाई करेगी। यहाँ होल नंबर 2 है एंड फ्रैक्शन 2/5, so it is like 2 point something, that is greater than 2 but less than 3. Similarly 32/9 में हमें कोशेंट 3 मिला और रिमाइंडर 5, तो हम इस नंबर को 3 5/9 भी लिख सकते हैं और ये नंबर 3 और 4 के बीच लाई करेगा। To represent the fraction on number line, we need to follow certain rules as given here. Suppose our fraction is in the form of n/d, जहाँ n न्यूमरेटर है and d डिनोमिनेटर। Denominator will tell us the number of equal division between two required consecutive integers. जैसे कि अगर हमारा नंबर प्रॉपर फ्रैक्शन है तो हम 0 and 1 के बीच d इक्वल पार्ट्स में डिवाइड करेंगे। अगर इम्प्रॉपर है और QR/D की फॉर्म में है तो डिवीजन Q and Q+1 के बीच होगा। Numerator n will tell us how many such parts we have to include. For proper fraction, we will count nth part starting from 0, and for improper fraction, we will count nth part starting from Q. The fraction may be positive or negative. Positive means right side of 0 and negative means left side of 0. चलिए अब हम इसे एग्जाम्पल के द्वारा समझते हैं। सपोज हमारा नंबर 1/2 है। यहाँ पर हम देख सकते हैं कि 1 2 से छोटा है तो इसलिए ये नंबर 1 से कम होगा और नंबर लाइन पर 0 और 1 के बीच आएगा। नीचे 2 हमें नंबर ऑफ इक्वल डिवीजन बताता है बिटवीन 0 एंड 1। तो अगर हम 0 एंड 1 को दो पार्ट्स में डिवाइड कर दें तो ऊपर का 1 हमें कितने पार्ट्स को इंक्लूड करना है वो बताता है। यहाँ पर ये 1 है तो इट्स फर्स्ट पार्ट स्टार्टिंग फ्रॉम 0, सो दिस इज अवर 1/2। सिमिलरली हम नंबर लाइन पर देख सकते हैं कि हर पॉजिटिव इंटीजर्स या फ्रैक्शन का एक करस्पॉन्डिंग नेगेटिव इंटीजर भी होता है। तो जितने डिस्टेंस पर हमें 1/2 मिला, सेम उतने ही डिस्टेंस पर अपोजिट डायरेक्शन में हमें -1/2 मिलेगा। सो ईजिली हम हर पॉजिटिव फ्रैक्शन या इंटीजर का करस्पॉन्डिंग नेगेटिव नंबर निकाल सकते हैं जो हमेशा 0 से दोनों साइड पर इक्वल में होगा। Can you tell us what would be the number at these divisions? It will start from 0/0, then 1/2 and finally 2/2. 2/2 is nothing but 1. Let us represent 2/3 and here the numerator 2 is less than denominator 3. Hence, this fraction is less than 1 and would lie in between 0 and 1. The denominator 3 tells us about the number of division between 0 and 1. So, we will divide it in 3 parts. The numerator 2 tells us to count 2 parts starting from 0, that is second part from 0. So, here first, second and this is our 2/3. And its corresponding value negative fraction will be -2/3 here. The distance between 0 and 2/3 is same as 0 and -2/3. So, if we know the positive side distance, we need not to divide on the left side. We can simply measure this distance OA and it would be equal to OB to mark our -2/3. All these in between division would be 0/3, 1/3 as it is first part, 2/3 and finally 3/3 as up to here. We have counted all the part which is this complete line segment from 0 to 1. Hence, this point would be 3/3 or 1. Similarly, for 4/7, as it is also less than 1, so we will divide the 0 and 1 in the 7 parts. As the denominator is 7, after dividing it, the numerator is 4, so we will count the fourth part starting from 0. 1, 2, 3 and 4. This is our 4/7. Similarly, we can measure the OA distance and if we go to the left side from 0, by the same distance OA we will reach the point B which is -4/7. इस बार हमने नेगेटिव साइड में डिवीजन नहीं किया है, but if we divide the negative side, that is from 0 to -1, then we will get the same value at same point after counting it from 0, considering the fourth part in left side. On the positive side, the rest of the division is shown here like 0/7 to 7/7. For 9/11, which is also less than 1, the 11 will be the number of division in between 0 and 1. 9 will tell us to count 9 parts starting from 0 and that is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our number. Similarly, we can also find its negative point on the left side. Let us represent the 3/2 on the number line. Here 3 is greater than 2, so that fraction is greater than 1. Without writing it in the form of mixed fraction, हमें हर यूनिट को दो पार्ट्स में डिवाइड करना पड़ेगा और our numerator is 3. तो हम 3 पार्ट्स कंसिडर करेंगे जो हम 0 से काउंट करेंगे. Now, after dividing the each unit and counting the 3 parts starting from 0, we get 3 by 2 here, that is 1.5. But it is always useful if we had considered it in the form of mixed fraction. हमें easily पता चल जाता है कि नंबर किन वैल्यूज के बीच में आएगा. जैसे 3 by 2 को हम लिख सकते हैं as 1 by 2. 1 एक होल नंबर है और ये नंबर 1 and 2 के बीच होगा, तो केवल हमें 1 and 2 के बीच ही डिवीजन परफॉर्म करना है जो इजी होगा. Suppose our next number is 31 by 2 and without converting it into mixed fraction, we have to mark every unit, that is from 0 to 1, 1 to 2 and so on. After dividing it into 2 parts, we need to consider 31 parts, which is very lengthy procedure. To avoid it, we will simply convert it in mixed fraction and we get 15 1 by 2. So the position of number is between 15 and 16. We will only divide this line segment in 2 parts and our first part counting from 15 would be the required number. 30 by 9. Let us convert it into mixed fraction. We get 3 by 9. 3 is a whole number and telling us the number 30 by 9 is lying between 3 and 4. The fraction 3 by 9 would provide the same information as earlier. 9 is the number of division and we need to consider 3 parts counting from. This time we will count it from 3, so our point will be here 3 by 9. Also, this number can be written as 10 by 3 and in mixed fraction 3 1 by 3. According to this data, we need to divide the line in between 3 parts and have to consider only the first part. We will get the same answer as earlier. Our next number is 19 by 4 and writing it in mixed fraction we get 3 by 4. All these 3 numbers tell us about the position of fraction 19 by 4. The whole number 4 indicates that the position of number is between itself and the next number, that is 5. The rest fraction denominator 4 tell us to divide the distance into 4 parts. And finally, this 3 is to count the number of part starting from 4. If we count 1, 2, 3, so this third part is our number 19 by 4. We all know that to represent any integer parts is easy on number line. We have represented here -6, -2, 2 and 4. Let us count how many numbers are there in between -6 and 4. We get -5, -4, -3, -2, -1, 0, 1, 2 and 3. These are all the numbers. Between them are total 9 numbers. Since the number was between -6 to 4, so on the positive side up to 4 we have 3 numbers and on the left side we have 5 negative numbers, and including 0 our total count is 9. Similarly, the numbers between 1 and 5 are 3, that is 2, 3, 4. -2, -1, 0, 1, these are all the 4 numbers between -3 and 2. Similarly, on the negative side, we can also find the numbers between any two negative quantity like here. We have learned that there would always be a countable or definite natural numbers or integers between two natural numbers or integers. Let us consider two rational number, -1/2 and 7/6. We have to tell how many rational numbers are there in between these two numbers. First, we make the denominator equal by taking the LCM. Here, LCM is 6, so the number becomes -3/6 and 7/6. So, we get total 9 numbers as -2/6, -1/6 till 6/6. But what if we multiply each term by 10? We get -30/60 to 70/60. And the number between -30/60 and 70/60 are -29/60, -28/60 till 69/60. You can easily count this number as up to 70. There would be 69 positive numbers. On the left side, there would be 29 negative numbers, and including 0, it will be total 99 numbers. Again, if we multiply by 100, we will end up with 999 numbers. And multiplying by 1 lakhs, then we will be having nearly 9.9 million numbers. If we can keep multiplying, then our count in between the numbers will also be keep increasing. We have to find out that we get countless or infinite rational numbers between any two given rational numbers. Since there are infinite number of rational numbers, then what would happen if we need only few rational number between two numbers? Consider -5/6 and 5/8, and we have to find out 10 rational numbers in between them. We will multiply the numerator and denominator by a suitable number to make our denominator equal. यहाँ हमने -5/6 में 4 से और 5/8 को 3 से मल्टीप्लाई किया, तो दोनों का डिनोमिनेटर 24 होगा। यहाँ इनके बीच हम नंबर फाइंड आउट करें तो नेगेटिव साइड में 19 नंबर मिलेगा एंड 14 पॉजिटिव साइड में, और इंक्लूडिंग 0 we will get total 34 numbers. We can take any 10 numbers. According to our need, we choose our multiplier. For example, here we need to find 10 rational number between -4/3 and 5/6. If we take 6 as LCM and multiply only -4/3 by 2, both numerator and denominator, then we get -8/6 and 5/6. In between we have -7/6, -6/6, 0, 1/6 till 4/6. Total 7 plus 1 plus 4 equals 12 numbers. We can take any 10. What if we need more numbers like 20 numbers? In that case, we will choose different multiplier. हमने पहले 2 से मल्टीप्लाई किया था, इस बार 4 से मल्टीप्लाई करें तो डिनोमिनेटर 12 मिलेगा, और 5/6 का डिनोमिनेटर 12 लाने के लिए हमें 2 से ऊपर और नीचे मल्टीप्लाई करना पड़ेगा. So finally we get our number as -16/12 and 10/12. On the negative side we will get 15 numbers, and on the positive side we will get 9 numbers as, and including 0, तो हमारे पास 25 numbers होंगे. So पहले हमारे पास केवल 12 numbers थे और अब 25 numbers हैं. हम यहाँ से 20 numbers चूज कर सकते हैं. There is one more method. हम सबने क्लास 7th में पढ़ा है कि मीन कैसे फाइंड आउट करते हैं. मीन या एवरेज हमेशा उन नंबर्स के बीच ही आता है जिनका हमने एवरेज लिया है. इसे एक एग्जाम्पल से समझते हैं. हमारे पास 2 नंबर है 1 and 2, और मीन फाइंड आउट करने के लिए हमें 1 and 2 को सम लेकर 2 से डिवाइड करना होगा. मीन्स 1 plus 2 divided by 2, we will get 3/2 और 1.5. और 1.5 हमेशा 1 से बड़ा और 2 से कम होगा। मीन्स हमेशा दोनों नंबर्स के बीच ही आएगा क्योंकि ये हमेशा मिड पॉइंट बताता है। हम मीन की आइडिया से रेशनल नंबर्स भी फाइंड आउट कर सकते हैं। If a and b are two rational numbers, then a plus b divided by 2 is a rational number between a and b, such that a plus b by 2 will lie between a and b. हमें हमेशा 2 पॉइंट्स मिलने पर उसके मिड पॉइंट को फाइंड आउट कर सकते हैं, फिर 2 पॉइंट का एवरेज ले सकते हैं और ये हम कंटिन्यूसली परफॉर्म कर सकते हैं। Hence, we can say that there are countless number of rational number between any two given rational number. Let us see this in action. Let us find one rational number between 1 by 4 and 1 by 2. We will use the average method and this can be written as 1 by 4 plus 1 by 2 divided by 2. Here LCM is 4, so 1 plus 2 is 3 and 3 by 4 multiplied by 1 by 2 will be 3 by 8. The same thing has been shown here on the number line. Initially 1 by 2 is the midpoint of 0 and 1. 1 by 4 we can also find out by dividing it into 4 parts and taking the first part. In the mid of 1 by 4 and 1 by 2 we get 3 by 8. This is the mean of these two numbers, and using our representation we can also find the 3 by 8 at the same place by dividing the whole line into 8 parts and marking the third point. जैसे कि हमने 1 by 4 और 1 by 2 के बीच 3 by 8 फाइंड आउट किया है, वैसे ही 1 by 4 और 3 by 8 के बीच में भी हम एक नंबर फाइंड आउट कर सकते हैं, फिर इन दोनों के बीच में एंड सो ऑन। इसलिए यहाँ से भी हमें पता चलता है कि हम दो नंबर्स के बीच इन्फिनाइट रेशनल नंबर्स फाइंड आउट कर सकते हैं। नाउ लेट अस फाइंड 3 रेशनल नंबर्स बिटवीन 1 by 3 and 1 by 2। पहले हम 1 by 3 and 1 by 2 का मीन निकालेंगे, जो यहाँ कैलकुलेट करके दिखाया गया है, और दोनों नंबर्स का मीन 5 by 12 है। 5 by 12 is the exact midpoint of the 1 by 3 and 1 by 2. क्योंकि ये मिड पॉइंट है इसलिए ये हमेशा 1 by 3 and 1 by 2 के बीच लाई करेगा। We can also find the same fraction 5 by 12 if we divide the whole line into 12 parts, and our fifth part will be the 5 by 12 which is also at the same position. हम 1 by 3 और 5 by 12 के बीच का मीन ले सकते हैं इनका मिड पॉइंट निकालने के लिए, जैसा कि यहाँ कैलकुलेट करके दिखाया गया है। एलसीएम 12 है और बेसिक एडिशन एंड मल्टीप्लिकेशन से हमें 3 by 8 मिल जाएगा। 3 by 8 is the midpoint of 1 by 3 and 5 by 12 which lie between 1 by 3 and 5 by 12. We can get the same fraction if we divide the line into 8 parts and third point would be the exact same position. But आपको हमेशा नंबर से डिवाइड करके नहीं दिखाना है। अगर मीन से फाइंड आउट करना है तो हमें केवल मीन के आइडिया को यूज करना है और जो कैलकुलेशंस है बस उसे ही शो करना है। Again, we will find one more number between 5 by 12 and 1 by 2 which is shown here. And the mean is 11 by 24, and dividing the line into 24 parts and selecting the 11th part counting from 0 would give us the exact same number. All these points are in between 1 by 3 and 1 by 2, so our 3 points which lying between them are 3 by 8, 5 by 12 and 11 upon 24. Thanks for watching the video. अगर आपको पसंद आया तो please do subscribe and share with your friends. Don't forget to press the bell icon to receive the updates.